Okay, so let's dive into something that's been kind of blowing my mind lately. Large language models. These AI systems that can write poems and
Indeed.
answer questions like a champ and maybe
Yeah,
even plan your next
it's
vacation.
incredible, isn't it? Yeah, and today we're going beyond just what they can do to take a deep dive into the how.
Okay.
Specifically, this fascinating thing called chain of thought prompting, or COT for short.
I am so hooked already.
We're good.
We've got some really cool research from Stanford and Google to unpack today a paper titled Chain of Thought Empowers Transformers to Solve Inherently Serial Problems.
Quite a mouthful.
Yeah.
But it gets right to the heart of it. This paper is all about understanding the limits of what these models can actually solve
Okay.
and how COT changes the game entirely.
So you're saying there are limits to what these AI models can figure out. I have to admit, after chatting with a few of them online, I was starting to think they could do anything.
It can definitely feel that way, especially with how quickly they're evolving.
Right.
But to understand their limits,
Hmm.
we need to sort of peek into the hood, so to speak.
Okay.
Imagine a transformer, which is the core of these LLMs, like a circuit
Okay.
with a bunch of logic gates, similar to how a computer processes information.
Okay. I'm vaguely remembering circuits from my computer science class.
Uh-huh.
Lots of ANDs, ORs, and not SERs.
Oh, got it.
Yeah.
The more of these gates a transformer has, and the more complex its connections,
Huh?
the more powerful it is.
Okay.
But even with tons of gates, there's a bottleneck.
Hmm.
The number of steps it can take to solve a problem.
Okay.
It's like trying to solve a massive equation in your head all at once.
Yeah. Possible, but
Yeah.
your brain might fry in the process.
Ouch, definitely not ideal.
Yeah.
So that's where chain of thought comes in. It's like giving the AI a notepad to scribble down intermediate steps.
Exactly. Coty is like breaking down a complex task into smaller, more manageable chunks.
Okay.
Instead of trying to do everything in one fell swoop,
Right.
the model can work through the problem step by step, just like we do.
And according to this paper, that small change makes a huge difference in what these models can achieve.
Precisely.
Wow.
The researchers actually proved that Coty dramatically expands the types of problems a transformer can solve. It's like going from being able to juggle 3 balls to juggling 10 simultaneously. It unlocks a whole new level of complexity. Okay, now that's impressive, but how many steps are we talking about here? Do we need to walk these AIs through every tiny detail?
That's what's fascinating.
Okay.
The paper found that even a relatively small number of COT steps can make a huge difference.
Okay.
We call this logarithmic 2t, meaning the number of steps grows much slower than the size of the problem itself.
Logarithmic. Okay, you lost me a bit there.
Oh, chuckles.
Can you give me a real-world example of this in action?
Absolutely. They tested this on a bunch of problems that are really hard for standard transformers to solve.
Okay.
One example is permutation composition.
Okay.
Imagine shuffling a deck of cards multiple times in a row.
Okay.
Without COPE, it's incredibly tough for the model to keep track of all the changes and predict the final order.
Yeah, I'm already lost just thinking about that.
Right. But with Cody, they found that the model could ace this kind of task.
Wow.
It's like giving the AI a clear set of instructions to follow, allowing it to handle much more complexity.
This is blowing my mind. So we're not just talking about theoretical improvements here. This has real-world implications for how we can actually use these AI models, right?
Absolutely. Imagine being able to ask an AI to analyze complex data sets,
Mm-hmm.
generate creative content with much more nuance,
Right.
or even write code that solves highly specific problems. Cody opens up a world of possibilities.
This is truly revolutionary stuff.
It is.
But I'm curious, is there a way to make these models even better at solving these complex problems? Like, are there other secret ingredients we haven't discovered yet?
That's a fantastic question,
Yeah.
and it's something the researchers explored further. They wondered if simply increasing the embedding size of the model, think of it like its memory capacity,
Okay.
could lead to even more improvement.
So are we talking about giving these AIs bigger brains? More RAM to work with?
Exactly. It seems intuitive that more memory would equal a smarter AI.
Oh, memory usually means better performance in my book.
You'd think so, wouldn't you?
Yeah.
But here's where things get really interesting. They found that while a bigger embedding size helps to some extent, it's the combination of COT and even a small embedding size that really unlocks the magic. It's like having a small team of brilliant strategists versus a huge group of people working independently. The power of collaboration and strategic thinking wins out.
So it's not just about raw processing power, it's about how effectively these models can use what they've got.
That's fascinating. But you mentioned they tested this on a bunch of different problems. What
Yeah.
were some of the other brain benders they threw at these AIs?
They focused on problems that are inherently serial, meaning they're really hard to solve without breaking them down into steps. They started with something called modular addition, which is actually pretty straightforward. Think of it like adding numbers on a clock face. You go around in a circle.
Right, so 10 plus 4 would equal 2 because you loop back to the beginning. Got it.
Exactly. And because you can basically add all the numbers simultaneously, it's not a very serial problem. But then they kicked things up a notch. Remember that card shuffling example we talked about earlier, permutation composition? That's one where made a huge difference. Then they looked at something called iterated squaring. Okay, now you're just using big words to make my head spin. What in the world is iterated squaring?
It's simpler than it sounds. Imagine you take a number square, square the result, and keep doing that over and over again. It's used a lot in cryptography, but the key takeaway is that it's really tough for a standard transformer to solve without Coddy. The model essentially gets bogged down in all the calculations.
So it's like trying to calculate compound interest over 100 years, but in your head with no calculator. No, thank you.
A perfect analogy. But with Coddy, the AI can break down the problem into manageable steps and solve it much more efficiently. Finally, they tackled a classic computer science problem. The circuit value problem.
Circuits again. Okay, remind me what that's all about.
Remember how we compared a transformer to a circuit with all those logic gates? Well, the circuit value problem is basically figuring out what the output of that circuit will be given a specific set of inputs.
So it's like solving a logic puzzle embedded in the AI's brain.
Exactly.
Yeah.
And it's a notoriously tricky problem to solve efficiently. But guess what?
Code to the rescue.
You know, the models with CoT were able to solve these circuit problems much more accurately than their standard counterparts, especially when those standard models weren't very deep.
Deep meaning they didn't have as many layers of those logic gates.
You got it. And it all comes back to that fundamental architecture.
Yeah.
But the takeaway here is that CoT isn't just a theoretical curiosity. It has a measurable impact on how well these models can solve real-world problems.
It's like we're giving these AIs a set of mental tools that allow them to approach problems in a more human-like, strategic way. But I can't help but wonder if we're already seeing such incredible results with CoT. What else are we missing?
That's the million-dollar question. This research has really opened up a whole new avenue of exploration. It suggests that we're only just scratching the surface of what these models are truly capable of, and there may be other simple prompts or techniques that unlock even more potential.
It's both exhilarating and a little bit daunting at the same time, isn't it?
Absolutely. It reminds us that we need to approach this technology with a sense of curiosity, but also with a healthy dose of caution.
Well said. But let's get back to CoT for a moment. The researchers didn't just test it in isolation, right? They also explored whether giving the AI extra hints could enhance its problem-solving abilities even further. It's like giving the AI a little nudge in the right direction.
Yeah.
Or maybe like slipping it some extra notes before the big exam.
That's a great way to put it.
Right.
And surprisingly, they found that while these hints did help to some extent,
Okay.
CoT consistently outperformed the hint-based approach, especially on those really complex, inherently serial problems.
So it's not just about feeding the AI more information.
Right.
It's about teaching it to think in a more structured, step-by-step way.
Precisely. It suggests that CoT isn't just adding information. It's fundamentally changing how these models process information, enabling them to tackle problems in a whole new way.
It's like we're not just giving them a bigger toolbox.
Yeah.
We're teaching them how to use those tools strategically.
Exactly.
Which makes me think, if simply prompting an LLM to think step by step can unlock this level of performance, what other simple techniques are we overlooking?
Right, that's what has me so excited. This research feels like a launch pad.
Yeah.
It suggests that we're just starting to understand the true depth and potential of these language models.
For our listeners who aren't knee-deep in transformer architecture and circuit complexity, what's the key takeaway here? Why should they care about chain of thought?
It boils down to this: CoT is pushing the boundaries of what we thought was possible with AI.
Okay.
For the everyday user, this means we're on the cusp of even more sophisticated AI tools. Think chatbots that can truly understand and respond to complex requests, writing assistants that can help craft compelling narratives, and so much more.
It's like we're going from AI that can merely mimic human language to AI that can truly comprehend and reason with information.
Exactly.
A pretty massive leap.
A huge leap, and it underscores the importance of understanding these models at a fundamental level.
Right.
It's not just about making them bigger or faster.
Yeah.
It's about unlocking their latent potential through clever techniques like COT.
It seems like a potent reminder that sometimes the simplest solutions can be the most powerful. Who knew that just asking an AI to think step by step could be so transformative?
It really is remarkable, and as we continue to explore this frontier,
Yeah,
it will be crucial to approach these advancements responsibly, ensuring we're developing AI that benefits all of humanity.
couldn't agree more. Well, folks, there you have it, a glimpse into the incredible world of chain of thought and its potential to reshape the landscape of AI. It's a fast-evolving field, and it's exciting to even imagine what breakthroughs await us just around the corner.
As always, this is just the tip of the iceberg.
Right.
We encourage you to delve deeper into the research, ask your own questions, and who knows, maybe you'll be the one to discover the next COT that unlocks even greater AI capabilities.
And on that note, we'll wrap up this deep dive into the fascinating world of chain of thought and large language models. Until next time, keep those brains engaged and those curiosity levels high.